Hello, Math 110. I am picking up on page 5 of your Chapter 4 notes. I'm going ahead and looking at conditional probability rule. Here is our conditional probability. I would like for you guys to add in number of A and B divided by number of A. So sometimes in problems you're given a probability, and other times you're actually able to just count it, as in the example right below. The example right below says the following data represents the number of speeding tickets issued to individuals in the past year and gender of the individuals. Determine the following probabilities based on the results of the survey. So if you notice too, there's totals already written in the table. So the first one says, what is the probability that a randomly selected individual was issued no tickets last year given the individual is female? So I need to find the probability of 0 tickets given female. And so using our formula up above here, I'm going to go ahead and look at the number one. So it's going to be the number of individuals that have 0 tickets, and I'm going to abbreviate that, and are female, divided by the total number of people that are female. So looking up here at our table, you'll notice the number of females total is 115. And the number of females that have 0 tickets is 97. Dividing this on your calculator, rounding 4 decimal places like we do for probability, 8435 would be your answer. So let's try the next one. The next one says, what is the probability that a randomly selected individual is female given the individual has not been issued a speeding ticket? So there's no tickets in the past year. So this time it's the probability that you are female given you have 0 tickets. And so again, using the formula that's up above, it's going to be the number of people that are female and have 0 tickets divided by the number of people that have 0 tickets. And so again, the number of people that are female and have 0 tickets is 97, divided by the total number of people that have no tickets is 168. And dividing this, rounding 4 decimal places, 05774. We're going to go ahead and cross off C. The next one down here, I want you guys to take a second to read. This is stating that according to the U.S. National Center for Health Statistics, 0.15 of deaths in the U.S. are 25 to 34-year-olds whose cause of death is cancer. In addition, 1.71 of those who die are 25 to 34 years old. What is the probability that a randomly selected death is the result of cancer if the individual is known? Now it says known, meaning that that's given, something that we know. Having them been 25 to 34 years old. So this is the probability that their cause of death was cancer. Let me move this up. Sorry, guys. Given that they were between 25 and 34 years old. And so again, this is going to be the probability, and this time again we don't have numbers. I have a probability in here, which is a percent, but we can rewrite that as a decimal. So this is the probability that they have cancer, or they die from cancer, I'm sorry, and they are 25 to 34 years old, divided by the probability that they're 25 to 34 years old, and they passed away. So going ahead and looking at the number of people that it says 1.71% of those who die are between this age. So that would go to be our denominator here, which is moving the decimal twice, 0.0171. And then the numerator, the probability that you passed away from cancer and you were 25 to 34 years old, is up here as 0.15%. So again, moving it twice to the left. And then going ahead and dividing these, we get 0.0877. And again, round 4 decimal places.